A pond of wet mine waste on a mountainside in the Italian Alps stopped behaving like a solid. It was 22 minutes past noon on a Friday, the 19th of July, 1985. By the accounts of that day, the valley below was full. Minutes later, the village of Stava was gone, and 268 people were dead. 11 years earlier, the mayor of the municipality had asked the mining authority whether the ponds on that mountainside were safe. A survey was carried out. It found the slope exceptional and the stability at the limit. That was written down in 1975. There has been mining under Mount Prestavel since the 16th century. What the 20th century wanted from it was fluorite, a mineral used as a flux in steelmaking and as the feedstock for fluorine chemistry. It was worked industrially there from 1934, and in 1961 a new processing plant opened, running 200 tons of raw ore a day. The method that plant used is called froth flotation. You crush the rock to powder, mix it with water, and use chemistry and air bubbles to float off the mineral you want. It works well. It also means that for every ton of fluorite you recover, you are left holding a much larger quantity of ground rock and water that you do not want. That leftover slurry is called tailings, and it has to go somewhere. At Prestavel, it went into ponds on the mountainside above the Stava Valley. The first was begun in 1961. It sat about half a mile from the valley floor and about 500 feet above it, on the slope directly above the village. The village was called Stava in the municipality of Tesero. By the 1980s, it was a holiday place. There were 5 hotels along the Via dei Mulini between Tesero and Stava, called the Dolomiti, the Rio Stava, the Erica, the Miramonti, and the Stava. The Albergo Stava was the oldest establishment in the valley, documented as an inn in 1896. There were campgrounds. There were apartment blocks that had been put up during the mining boom to house workers who had come from other parts of Italy. So 2 things were growing in that valley at the same time. A peer-reviewed study of the disaster, co-authored by Tossati, a professor of engineering and environmental geology at the University of Modena and Reggio Emilia, puts the collision plainly. As tourist development increased, so did the number of people exposed to a hazard, and that was totally ignored by the people in charge of building the basins. By the accounts of that Friday, the hotels were full. The ponds had been up there for 24 years. Children had grown up underneath them. In all that time, they had never harmed anybody. Nobody built a dam at Stava and then filled it with waste. The method used there is called the upstream method. You build a small starter wall, and you spray the wet tailings in behind it. The heavier sand settles out near the wall, and the finer silt and water carry further back into the pond. Then, once that sand has drained enough to stand on, you build your next lift of wall on top of the tailings you have just deposited. Then you do it again. It is called the upstream method because every new crest sits further back than the last, out over the pond. The wall is made of the waste. The structure holding the material back is built out of the material. It is the quickest way to do it, and it is the cheapest way to do it, and it is the most dangerous. It can be done safely, but only under one condition, and the condition is drainage. The deposited tailings have to consolidate. Water has to be able to leave the pile faster than new waste arrives, so that the material compacts into something that carries load. Take that away, and you are stacking a hillside out of saturated slurry. Now look at what was actually there. The first basin was placed on marshy ground on a slope of about 25%. In April of 1961, the operating company applied to the Civil Engineering Office for permission to build an embankment 9 meters high, call it 30 feet. By 1969, that basin was over 80 feet high, nearly 3 times what had been applied for in 8 years. And because the first basin had outgrown itself, at the end of 1969 they started a second one, uphill of the first. It was begun with no provision for anchoring it to the ground and no provision for draining it. As it grew, the toe of it came to rest partly on the silt of the lower basin. The foot of the upper structure was standing on the soft waste of the lower one. The water was drained through pipework that ran inside the basins and out through the walls themselves, where it sagged under the weight of the silt piling on top of it. By 1985, the whole facility was close to 200 feet high, around 60 meters, holding some 300,000 cubic meters of tailings, which is about 11 million cubic feet. The outer face stood at about 39 degrees. That last number is worth a moment. Pour dry sand into a heap, and it will settle into a cone somewhere in the low 30s of degrees, because that is as steep as loose grains will hold one another without help. The wall above Stava was built steeper than that. What kept it standing was the water pressure inside it staying low enough for the grains to stay locked together, which is another way of saying that the whole structure depended on the drainage. A heap of wet sand, if you overload it, slumps. It slides a little way, and it stops. Keep that picture, because it is not what happened here. In 1974, Flormine moved to raise the second basin further. The mayor of Tesero was a man named Giuseppe Zanon, and he wrote to the mining district of the autonomous province of Trento, the public authority responsible for supervising the site, to say that perhaps it was not advisable to raise the second basin as well. The district agreed that a stability verification should be carried out. It was then assigned to engineers chosen by Flormine. Flormine was the company that owned the ponds. The check was performed in 1975 by an engineer named Girardini, and it was performed superficially. A series of surveys that the job required were simply not done. Even so, working with less information than he should have had, Girardini reached the finding that matters. The slope of the upper basin's bank was exceptional. Its stability was, in his own assessment, at the limit. The American engineering summary of the same assessment puts it in the flatter language of the profession. The downstream slope of the upper dam was very steep, at 39 degrees, and its stability was marginal. That finding went from Flormine back to the mining district, and from the mining district back to the municipality of Tesero, and by the time it arrived, it had become an answer rather than a warning. The expansion could go ahead, with due precautions. The precaution that was actually taken was a reduction of the slope gradient. The basin was then substantially enlarged, and the 1975 verification was not one check among many. Across more than 20 years of operation, no serious stability check was carried out on that facility by the mining companies or by the public supervisory departments. Not one. The 1975 verification was effectively the only time anybody looked, and it was carried out by the owner on its own structure at the invitation of its regulator. The facility then gave 2 more warnings, and it gave them in its own voice. In January of 1985, the water drainage system partly failed and the ground opened. There was a landslip and a sinkhole in the upper basin. In June of 1985, 5 months later, a sinkhole appeared in the lower basin. Investigators found afterwards that the pipes had been laid badly inside the dams and were sagging under the load of silt above them. Both failures were repaired, the lower basin's pipes were rerouted, and water continued to be pumped into the upper basin, behind a drainage system that was known to be failing. Something else was happening in those final years, and it came out of the technical analysis rather than the courtroom. The sand for the wall was placed by hydrocyclones mounted on rails, which were moved along the embankment as the wall grew. In the last 3 years before the collapse, that stopped. The cyclone was left in one fixed position near the washery, and the coarse tailings were spread along the wall instead by front-end loaders and trucks. Machines that heavy, driving on a bank of wet sand, put vibration into it, and the study is explicit that this interfered with the material settling as it should have. In the last 3 years, they were driving trucks on it. The question and the answer both happened on paper, a decade before anybody died. Zanon's letter went to the mining district, and the mining district filed it. Remember that, because a court is going to read all of it. 6 weeks after that second sinkhole, the ground let go. At 22 minutes and 55 seconds past noon, the downstream face of the upper embankment failed locally as the water table inside the pile rose behind the drains that had been failing since January. That first movement was local. What it did was remove the support from everything behind it, and what was behind it was 110 feet of loose, saturated, uncompacted tailings that had never properly consolidated. There is a word for what happened next, and it is the entire mechanism of this disaster. Liquefaction. Loose saturated soil is grains of sand and silt resting against each other, with water in the gaps between them. The grains carry the load. If that soil is loaded or unloaded faster than the water can drain away, the water starts taking the load instead of the grains, and as it does, the grains stop pressing against each other and the material stops behaving like a solid. It is not that it gets wetter, It is that almost all of its strength is gone, and what is left cannot hold a slope up. There was no earthquake here. This is the version that happens on a still day, under nothing but the weight of the pile itself, which is why engineers call it static liquefaction. That same peer-reviewed study describes a progressive rise in pore water pressure under the upper dam, driven by pond conditions that went unnoticed. That is the difference between a slump and a flood. Around 180,000 cubic meters came off that mountain, call it 6.5 million cubic feet, and it picked up another 1.5 million cubic feet of soil, trees, and buildings as it went. The upper basin fell onto the lower one. The lower one was overtopped and destroyed almost immediately, and its contents joined the flow. It started down the valley at around 20 miles per hour, and it accelerated. At its fastest, it was moving at about 56 miles per hour, roughly 90 kilometers per hour. The commonly cited figure is that 90. The computed peak in the technical literature is nearer 100, and this script is not going to pretend the difference matters to anybody who was standing in front of it. The village was about half a mile below the lower dam. It was 22 minutes past 12 on a Friday in July, and by the accounts of that day, the hotels were full. 3 of them were completely destroyed: the Stava, the Erica, and the Miramonte. With them went 53 homes and 6 industrial buildings. 8 bridges were demolished, and 9 more buildings were left seriously damaged. In 5 minutes, the settlement of Stava no longer existed. The flow ran 4.2 kilometers, about 2.6 miles, to the river Avisio. It covered 107 acres and left mud between 8 and 16 inches deep across all of it. The rescue effort was immediate. It recovered almost nobody alive. One young woman was pulled out of the rubble of a hotel and died some days afterwards. The Stava 1985 Foundation holds the record of the dead. Of the 268, 28 were children under the age of 10. 31 more were young people under 18. 120 were women and 89 were men. 71 of them were never identified. On the 24th of July, 5 days later, a ministerial commission of inquiry was appointed by decree of the President of the Council of Ministers. Experts were separately appointed by the Law Court of Trento. On where the ponds had been put, the ministerial commission wrote that even a rough analysis of the ground they had been placed on could immediately prove that no other siting could be less appropriate. It went further than that. Such a macroscopic error in the choice of location, it wrote, can only be justified by poor general consideration. The experts appointed by the court in Trento were blunter still. Their finding was that the settlement system as a whole constituted a continuous threat looming over the valley, and that the upper bank was bound to collapse as a result of the slightest alteration to its precarious stability. Not that it failed, that it was bound to. The engineering arrived at the same place by arithmetic. In 1995, Chandler and Tosatti published an analysis of the failure in the Proceedings of the Institution of Civil Engineers, and it is the source the technical accounts of Stava keep pointing back to. Their verdict, as it is reported in the engineering literature, was that the dams had been built with an unacceptably low factor of safety. A factor of safety is the ratio between the strength holding a slope up and the load trying to pull it down. At 1.0, the structure is exactly on the point of failing, so for something of that size standing over a village, the engineering literature works to a comfortable margin above it. The figures reported from their analysis, calculated for 4 different assumptions about where the water table sat inside the dam, are 1.35, 1.21, 1.04, and 0.76. The trial opened in Trento in April of 1988 and ran to July. There were 12 defendants and 534 civil parties. 10 men were convicted of culpable disaster and multiple manslaughter. There were mine directors, going back to the man who ran it from 1967. There was Montedison's mining coordinator. There was the general director of Flormine. There was Ghirardini, who wrote the 1975 report. And there were 2 officials of the mining district of the autonomous province of Trento, Perna, the district's chief engineer up to 1975, and Curo Dossi, the district's chief engineer after 1975, the state's own engineer on either side of the check. The regulator was convicted alongside the company it was supposed to be regulating for having completely omitted checks on the structures. The safety check on the dams above Stava was assigned to the company that owned them, and what came back down to the village was permission to make them bigger. The sentences at first instance ran from 2.5 years to 5. The Court of Appeal in Trento cut them in December of 1989 and acquitted 3 men outright. A correspondent for La Repubblica wrote at the time that there were 7 convictions for that immense disaster, that the harshest were 4 years, of which 3 were remitted, and that nobody would go to prison. He was right. The Court of Cassation restored the 3 acquitted convictions. A second appeal in Venice reaffirmed the sentences, and the final ruling came on the 22nd of June, 1992. None of those sentences was served in prison. The civil actions ran for years. In 2004, one settlement paid more than 132 million euros to 739 people from Edison, from Eni Snam, from Finimeg, and from the autonomous province of Trento. Prealpi Mineraria, which had been running the mine at the end, was bankrupt and paid nothing. The province's share was 27%. The Foundation's account of that settlement records without comment that compensation for the loss of human lives was quantified as it would have been for road accidents. The 71 who were never identified are buried together at the cemetery in Tesero. Some things did change. The Stava 1985 Foundation was set up and now runs a documentation center in the valley and supports teaching in geotechnical engineering at the University of Trento. In April of 2006, the European Union published Directive 2006/21/EC on the management of waste from extractive industries. And on the 1st of June 2011, the Italian Parliament voted unanimously to establish a national day in memory of the victims of environmental and industrial disasters caused by man. The upstream method did not end at Stava. It is still in use, and it has failed since. That is its own autopsy, and it will get one. A former magistrate who worked the Stava case, Ancona, has said 2 things about it in the years since that are worth carrying out of here. The first is that Stava was an example of the banality of evil. The second is that to forget it means to kill those people again. The question Giuseppe Zanin asked in 1974 was a simple one, and it got a correct answer. An engineer looked at the upper basin and wrote that the slope was exceptional and the stability was at the limit. That was true when he wrote it. It stayed true for the next 10 years, and it was true at 22 minutes past noon on a Friday in July. The report was not lost. Nobody hid it. It went to the authority that had ordered it, and the authority sent word back down to the village that the ponds could be made bigger, with due precautions. Everything that happened afterwards was a decision about what to do with a sentence that everyone had already read. Nature runs its own autopsies. Those are on Tornado Autopsy.